Okay, in advanced chemistry, I expect you to know the symbols in the periodic table, so you need to start memorizing them as soon as you possibly can. There will be competencies that see how well you know the symbols. Symbols are called symbols because they actually used to be kind of symbols. Now we think of symbols technically as letters, and a lot of them make sense. They just kind of start with the first letter of the element. So hydrogen is a capital H. But then, of course, the next element is helium, and we've already used a capital H, so a lot of times they do something that makes sense, like He. That'd be helium. Lithium is Li. Calcium is Ca. How come it's not C? Because we already used C for carbon. So a lot of these symbols can make sense. Some of them, though, you'll get to, and they don't seem to make a whole lot of sense. Well, they do make sense if you just knew the other language that the element was in. So Latin for potassium is called kalium. Kalium. Well, the symbol for potassium is a K. Latin for sodium is natrium. So the symbol for sodium is Na. So some of these don't seem like they make a lot of sense on the surface, but most of them all make sense if you just happen to know the other language. We have some kind of fun ones. Plumbum, which is Pb, that's Latin for lead. We have hydragyrum, that's Hg, that's not hydrogen, it's mercury. We have ferrum, which is Fe, that's for iron. So we have a lot of symbols that are a little bit strange, and the sooner you start memorizing those, the better. So those are symbols. Now, if we take elements and put them together into compounds, we have what we call formulas. So these over here are not formulas, these are symbols. But I could put symbols together, and later on we'll make bonds and stuff, and we'll talk about that more. But I could get formulas like H2O. Formulas will consist of a small number behind the element, which is called a subscript. A subscript, below writing is what that means, below writing. A subscript, and the subscript tells you how many atoms of that particular element that is behind that you have. So there's a 2 behind the H, you have 2 atoms of hydrogen, there's nothing behind the oxygen, so that means you have 1 atom. So this has a total of 3 atoms, 2 hydrogen and 1 oxygen. We can also put out in front of these things what we call coefficients. So I could say I have 4 molecules of water, 4 H2Os. And if I did that, then I would expect you on the competency to be able to tell me how many hydrogen atoms are there. Well, you take the coefficient times the subscript, and there'd be 8 hydrogen atoms, and there'd be 4 oxygen atoms. So I can write formulas for compounds, and later we'll learn how to write them, but right now we just kind of be able to recognize a formula as opposed to a symbol. And if I put a coefficient on it, I would expect you to be able to tell me how many atoms there are of a given element. So we'll just start with one real complicated right from the beginning. We'll do 3 NH4 3PO4. That's complicated. That's called ammonium phosphate, and we have 3 of those ammonium phosphates. So if I asked you how many oxygen atoms there would be, well, you have a 4 as a subscript, and out in front you have a 3, clear out here in the front. So 3 times 4 would be 12 oxygens. How many phosphoruses? We would have 3 phosphoruses. Okay? This 4 here does not go for the phosphorus, it just goes for the oxygen. So 3 phosphoruses. How many hydrogens? Well, I have, in the parentheses, I have NH4, and I have 3 of those things that are in the parentheses. So I would take 3 times 4 to get 12 hydrogens, but then I'd have to take it times the 3 out here in the front, so I would have 36 hydrogens. And then I would take 3 times nitrogen, it would be 3, times 3 out here in the front would be 9 nitrogens. And then, of course, I would have, well, I guess that's all of it. That's it. I only had 4 elements. So 12 oxygens, 3 phosphoruses, 36 hydrogens and 9 nitrogens. So I'll give you a compound or a formula, and I'll put a coefficient out in front of it, and you should tell me how many there are. A lot of times it's just really good to cover up your coefficient, figure out how many atoms there are in the thing, and then go ahead and take all those times the coefficient. So the difference between symbols and formulas: symbols are like 1 to 2 or maybe 3 letters. Some of them we have like octium. We'll talk about that when we talk about IUPAC. But they're just symbols that represent the elements. You put the symbols together, the elements together into compounds, and then we have what we call more complicated formulas.